Now we go with the next speaker, which is Federico Simões. And the topic is assessing the impacts caused by drought in eucalyptus plantation in Mato Grosso, Brazil.
Okay, I promise to be quick in the next hour. In this study, I was trying to identify the main variables related to the drought in the eucalyptus plantation in the northeast of Brazil. The eucalyptus was introduced in Brazil in 1865 in the south, mainly to produce firewood for the railroad. And the government in this time support financially the research and the implementation of new forests. And they start to research in the south, and they increase the mean annual increment from 20 to 60 cubic meters per hectare by year. I usually play that you can hear the tree grow in the forest. It's growing fast. And it's eucalyptus plantation, it's really important in Brazil. We have in 2020 9 million hectares, and it represents 1.3 of the gross domestic product, the GPD, and employ around 3.8 million indirect and direct employers. And also it's important to release the pressure from the natural forest, and also to stock and sequester CO2 from the atmosphere. According to the NASA, 2019 was the hottest year since 1880s. And in this situation, many forest management plans was put on test, and also the species. And some species show that was not so resistant to drought, long periods of drought. And in this picture, you can see a photo in 2019, and after the drought, like clear was a huge damage in the plantation. And the study area, it's a private area, 1,400 hectares. They start to plant in 2006 with seminal species, seminal seedlings. And at the same time, they bring the clones from the south, and they did some trials to see which clone was the most productive ones. And after 7 years, they start to implement these clones. Now we have 4 different genotypes, 6 different density, and 57 annual units. We did the forest inventory in 2019, 2020, with 153 plots, 18 meters radius from each plot, measured each year around 7,000 trees. And we took this data to analyze some basic information like yield tables, sorting, and one of the important data that I want to show is the mean increment annual from 2020 and from 2019, 2020 after the drought. It was a significant reduce from the increment. Of course, for the lack of water and when we analyze this with linear mix effects, it was clear and obvious. Some clones was more susceptible for dying, and the higher density, the higher mortality, and the youngest trees was also more susceptible to die. And when we add some random effects to this, it shows the same results. But we want to know overall from the area. So we did we flight with a standard drone with a RGB camera and collect 6,500 pictures and processing this data with 38 ground control points to get a mosaic of RGB, digital surface model, and a new green vegetation index. And we stack all this information, make the segmentation to stratify, to split the information, and we train the plots. We use not a tree level, but we use the plot level. And we use two classes, mortality with less than 5% and more than 5% in the plot. And we run the model and analyze the results. This is just like some outcomes. The RGB image, the ground, the digital surface model, and the segmentation with 18 meters radius, the vegetation index, and in the right, the classification, the two classes, less than 5, more than 5. We had a quite good accuracy with 89%. And when I summed all the areas, the clones was the ones with more mortality, with the same we had with the ground data. But the landowner wants to know financially. He cares about money. So we did some analysis to see with this deadwood, he cannot sell. He cannot do the same product he could do with a live tree. And so I did the assortment of the class, the diameter class, evaluate each class, and transform it to firewood, because now he's gonna sell it as a firewood, cheaper. So it's like $3,500 per hectare of losing money. And this means $5 million for the whole project, US dollars. Some comments. Remote sense, it's time consuming because it was the processing data with the amount of information, with the quality we have. We had 7 centimeters pixel, so it was a very high resolution. It was impossible to process in a normal computer, so I had to resample it for 1 meter. And the homogeneity of eucalyptus plantation, it's also another problem that I face. The software cannot make the type points from the image because it's the same. He cannot find a point to match. And also the economic analysis, like there's a lot more to do here, to study and to see, to get better results for the landowner. Like he could plant less, have lower implementation cost, and maybe the same amount of money at the end, or even more. And the conclusion, it's like basic forest management. Choose the right genotype, because the company was only concerned about production. They never concerned about drought. They never concerned about other problems that may occur in the 8 years, 10 years project. And also density. They try to put so many trees, and if they reduce, they will have the same results. And that's it. Thank you.